Hello, class. Sorry I can't be there with you today, but I luckily brought home the hover cam to make a different video, and we'll make this video to start. So first thing is I want to let you know you're supposed to get 4 handouts today. So if for some reason you didn't get them, please go ask in the math office. Mrs. Giovini, Mr. Schneider, or Mrs. Palatucci will have them for you. One, it says free response prep, FTC part 1. We're going to use that in class today. One says optional extra practice, free response. This is really good extra practice that's just kind of a different type of problem. And you review a lot of skills like chain rule and product rule in there. So if you have time, I would do that. Use Mr. Calculus's solutions. This one that says optional extra practice multiple choice. This one, it's possible that not everyone wants to do it. You only want to do this if you're feeling very confident with everything else we're doing and you're like really going for that 5, because what this is review of a few topics that you may not remember. So for example, like inverse trig functions. To be honest, inverse trig functions are probably likely to show up exactly once on the exam. So what a lot of students choose to do is not memorize all 6 of the derivative formulas. Some students choose just to memorize the tangent one or just the sine one because those are the most likely ones to show up. But some students will go for all of it. They'll try to get all those. The derivative rules are in your chapter 3 stuff to know for the inverse trig functions. And then I do have answers and hints back here, as well as like a little video. So again, this one, it's possible that not everyone decides to do this, and that's totally fine. It's only if you're feeling really confident with everything we're doing. And if you have any questions, you feel free to email me, and I'll do my best to get back to you guys. The 4th handout is the homework. Reminder, I'm planning to have 4 homeworks. This is the 3rd one. And next week, sometime after the exam, you'll pick 3 to hand in, and I'm going to grade them. So make sure you're actually making corrections. And because when I say I'm going to grade them, I'm actually looking at like completeness and correctness as well. All right, so those are the 4 handouts for today. And what I'd like to do first today is take a peek at the homework. So for the homework, here's the first one. Wasn't that nice? So that's just a little reminder that sometimes you do get a problem that is like quick to solve on the AP exam. The next one here, number 12, is a U substitution problem. It's in a little bit of a different format because they're actually not having you evaluate the entire thing. They're just having you transfer everything over into U's and DU's. So what you want to remember there is they're even telling you what to use for DU. So what you want to remember here, one of the big things is using the changing the upper and lower limits of integration to change them from X values to U values. And again, if you have further questions on this, I'm sure you can help each other in class, but feel free to reach out to me. And then number 20 is the annoying inverse theorem. So just to review that with you real quick, this is likely to show up exactly once on the exam. So just to review it in case we can get it right, you'll know it when you see basically inverse. So there's only 2 places inverses will probably show up. One will be an inverse trig function. And again, you'll decide whether to memorize those formulas or not. And one will be the annoying inverse theorem. I would go for this one. So the annoying inverse theorem says, and that's just what we call it. It's from section 3.8, I think. It's definitely chapter 3 summary page. So what we do here with inverses is we first kind of identify a point. So if 0, 1 is on F, then the inverse has to have 1, 0. And we want to find the value of G prime of 1. Now, we don't have any information here about G except that it's the inverse. So what we're going to do instead is find F prime of 0. So we find the inverse, the derivative of the inverse at the corresponding X. So we want the derivative of F at this X value, the derivative of G at this X value. And the relationship between those is that they will be reciprocals, not opposite reciprocals, just reciprocals. So what we want to do is we want to find F prime. I would not cube that. I would just use the chain rule. So swing the 3 around, reduce the power by 1, multiply by the derivative of the inner function. Clean that up if you like. And then if you want to find the derivative evaluated at 0, you're going to have 6 times 1 squared. You get 6. So if this equals 6, then the derivative of the inverse at the corresponding X value will be the reciprocal, which is how we get 1/6 for that one. Okay, so that's the multiple choice. As far as the open-ended, I wish I was with you so I could ask you how it went with the bananas problem. It's so silly that it's bananas. But hopefully it went really well. I hope you see the parallel between this and what we did in class with the people waiting in line for the escalator. Because we have a function where the bananas are being removed. We'll be subtracting that out. We have a function where the bananas are being added. I do like Mr. Calculus's solutions for these problems. For part C, he did 2 methods. The first method is the one that I would suggest. And one thing I want to mention is when you look at part B, it asks you to interpret the meaning of f prime of 7 in the context of the problem. What I want to let you know is it doesn't have to sound good. It can sound kind of awkward as long as it's correct. So the answer that Mr. Calculus gave is the rate that customers remove bananas is decreasing by pounds per hour. And you can word that different ways. And since F is the rate at which customers remove bananas, what you can say is you could also say it's the rate at which the rate that the customers remove bananas is changing. So once again, that was the rate at which the rate that the customers remove bananas is changing. That would also work. And to get the units, again, this is very like awkward. So it's pounds per hour squared if you want. Kind of like if you think of like acceleration, you know how it's feet per second for velocity and then feet per second squared for acceleration for that derivative. So you could do pounds per hour squared, or you could do pounds per hour. And again, it doesn't have to sound nice. It can be kind of awkward here as long as it's correct. So since this is measured in pounds per hour, if you do the rate of change of this, then it's going to be pounds per hour. Sounds awkward, but it is technically correct. So just to make you aware of that. All right. And that's all I want to say on the homework. If you have any questions, you can reach out. I'll do my best to get back to you. And what I forgot to mention regarding the tests you guys took. I sent everyone who took the test, I sent you a message with your score and some feedback on what you might want to review. And anyone who didn't take the test yet, I sent you a message to try to schedule a makeup. So check those messages. Let me know if you have questions. All right, and we're going to look at a free response type of problem today. So today's type of free response problem is this kind. And so like I said, I identified some different types of problems. We have the ones with the rates of change, like the bananas problem you did. And then we also have the other ones that we've seen so far. So the one I want to review with you today is one that often relates the graphs of f prime, and f double prime, and often involves FTC part 1. This example does not have FTC part 1, but when you do the homework tonight, but I threw that in the title because a lot of problems that are very similar to this will involve FTC part 1. So when you do the homework tonight, if you do the optional one, that's going to have this right here. And since this is the graph of f, do you see how that's the integrand? If we find g prime of x, we'll be ddxing this integral. And since we are finding the derivative of the definite integral with a number on the bottom and just the variable x up top, that becomes f of x. So this right here, this is the graph of f if it's also g prime. And that's why, again, so you recognize this as FTC part 1. A lot of times the problem that we're going to see in class today is presented with the function defined by an integral. So you might want to go for that optional one in that homework. Okay. So let's take a look at the one that we have here. So this particular example has a graph of f prime. Let me make that clear. And the derivative, f prime is the derivative of twice differentiable function we're looking at from 0 to 8. There's horizontal tangents at 1, 3, and 5. They're just telling you that the slope is 0 at those 3 locations. It looks like that, but they're just confirming it for you. And then we have an initial condition of f of 8 equals 4. So the first thing we want to do is find all values of x between 0 and 8 where f has a local min. So we don't need to consider the endpoints because it's strict inequalities. And to have a min, what we want to remember is that f has a min where f prime changes. Let's see, we want f to go from decreasing to increasing. So we want f prime to change from negative to positive. Did you see what I did there, by the way? Like, I don't memorize that, like, oh, f prime changes negative to positive as a min. I think, how does that relate to f? So when f goes from decreasing to increasing, we know there's a min. That's when f prime changes from negative to positive. So if you look at the picture, f prime is positive here, f prime is negative here, and it's positive here. So that happens right there, and that's x equals 6. So that's why that's written on your handout. And it says justify your answer, so you want to give a little explanation there. Now, for the absolute min of the function, this one is actually a little tricky, and it involves using a variation on FTC part 2 that we want to review here. So the absolute min, first of all, is going to occur either at 0, at 6, or at 8, because we reviewed the other day that it's going to be at an endpoint. That's the EVT, the extreme value theorem, and an endpoint, or where the derivative changes negative to positive. It's not going to happen here because that's the location of a max, because the derivative changes positive to negative. So what we have to do is we have to find the values of f of 0, f of 6, and f of 8. Now, f of 8 is actually given, because f of 8 is given up here. It's 4, so we have that one already. I think I wrote that one last. And then for f of 0, it can be a little tricky, because for f of 0, you might look at this and just assume, oh, then just 0, because a lot of times it is, but that depends on the initial condition. So if you want to find f of 0, what we have to do is use a variation of the FTC part 2. So if you recall, if you have something set up like this, we had, when we were solving initial value problems, sometimes we moved this term over and we ended up with a way to solve initial value problems when we don't know the integrand. If we know how to find the antiderivative, we just do that and then do FTC part 2. But when we don't know how to find the antiderivative, so if it's something kind of weird where you have a picture, or if you're doing a calculator problem, you can use this as like a formula instead. So if we want to find f of 0, that's my b, so 0 is going to go up here. And then the initial condition is that I'm given f of 8. So I'm going to put f of 8 here and 8 here, and then I have that function. And I use t dt here. You could use x. I think I used x in the problem the first time I did it. Okay. So what we're looking at next is that f of 8 is 4. That was given in the problem. And we're doing the definite integral from 0 to 8. And in order to evaluate this, we need to use the picture. So if you look at the picture, remember how the areas were given. So if you wanted the value of the integral, you can use these areas. Now the thing is, you can't just straight add those up to find your answers because of this initial condition. So what we need to do here is we need to, well, first of all, this goes from 8 to 0. So this is a little surprise for you because we haven't done this in a while. You want to go from 0 to 8 because you want to go from left to right. You want to go from small number to big number. So if we rearrange that, if we're going to reverse the over integration, we put a negative out front. And what we can do now for this definite integral, we can just add the areas. So I think I misspoke a moment ago. I said to find the value of this, you can't just add. You can just add. To find the function value, you can't just add up the areas because you need to take into account the initial condition. It's kind of like finding the value of the plus c when you're doing antiderivatives. So to find the value of the definite integral from 0 to 8, we're going to add the 2, the 6, the 3, and the 7. And that's where those numbers came from right here. And if you add all up, you get negative 8. There is another way to do this. This is the only way I'm going to show in the video because it works for other types of problems. So I won't mention the other way to do it because this one will work for you every time. So once again, to reiterate, if you want to find the value of the definite integral from 0 to 8, you can just add up those areas. But to find the actual function value, you have to incorporate the initial condition. So then to find f of 6, what we have to do is we have to kind of use that same kind of formula. And again, we have to reverse the order of integration because the way we built that is going to be 8 on the bottom, 6 up top, and we want the lower number on the bottom. So we have to reverse the order of integration, put a negative. If we find the value of the definite integral from 6 to 8, from 6 to 8, that area is 7, and it's above the x-axis, so I count it as positive. And then I get my final answer there. So if we compare our values, we have negative 8, we have 3, and we have 4. So the absolute minimum value is negative 8. And remember, for vocab, if they want to know absolute min or the min value, they want the y value. If they want to know where it occurs, then they want the x value. Okay, and then the next one. So part C is on where's the graph both concave down and increasing. So we'll just kind of look at what I wrote out here. This is section 4.3 in your textbook. This is relating the first derivative to the second derivative and the original function. Okay, so that's section 4.3 in your book. So in order for f to be increasing, I'll start with that. F prime has to be positive. So F prime is positive here, all of these, and here. And then F is to be concave down, it's where the second derivative is negative, but if you don't have the second derivative, you can use where F prime is decreasing. These are basically interchangeable. So if we look at this function, F prime is decreasing here, F prime is decreasing here, and that's it. Now, if we want the function to be concave down and increasing, then we don't want this part, okay? So if you look at this part, F prime is positive, F prime is decreasing. So that means F prime positive means the function F is increasing. F prime decreasing means that F is concave down. And that's what we want. Here we have the same thing. We don't want this portion because F prime is negative, which means F would be decreasing. That's what we don't want. So even though here F prime is decreasing, because this is F prime, so even though F prime is decreasing and we would have concave down, this does not satisfy what we're looking for because F would be decreasing, not increasing. You can slow that down and watch it again if I said it too fast. But again, that link between F and F prime and F double prime is what we're investigating here. And I used interval notation. You can do inequalities if you want. And but it does say open intervals, so don't put the brackets on that one. Okay, and then the last one is kind of different. It doesn't really look like all the rest of the parts. So function g is defined by this. I see it's f of x and then a cubed outside, so I immediately think composition, I think chain rule. And we're given that f of 3 is this. We want to find the slope of the line that's tangent to the graph at x equals 3. So I think you can let's look at this here. Okay, so we have this information and we want to find g prime of 3. Yeah, that's what it said. So for g prime, we start by finding g prime using, like I said, the chain rule. Okay, so here's g prime. And then for f of 3, we're given that y value, so that's how I got the negative 5 halves. And then in the chain rule, I also have f prime of 3, so that's f prime of 3, I go to the graph for that. So f prime of 3, if you look back at the graph at x equals 3, f prime's value is 4. Okay, and so that's how I got the value. And if you're doing the AP exam, you can stop here. You don't have to simplify that, or you can stop here. AP grading rules. So you guys decide where you're comfortable with that one. If this one stumped you a little with that chain rule thing, if you recall at the beginning, I mentioned that optional extra practice for your response. This has great practice with chain rule, product rule, all that good stuff with a function, with a graph, and with a table. This is a really good one to spend some time on. And I do want to say here at the end, I try to say this every tomorrow as well. In order to do well on this exam Monday, you really need to spend some time out of class. We're doing a lot of review in class, but at the AP level, it is expected you're doing something outside of class as well. So I hope you're working through the 2003 multiple choice packet. If you have any questions on that, you can let me know. And I would even suggest, I won't be there for extra help like I had planned, but I would suggest you guys get together. Why don't you get a group and get together for 20 minutes during lunch each day and knock out a few problems so that you can get that extra practice you need. Don't save it all for Sunday. Make sure you budget your time. But if you want to do really well on the exam, you're going to have to do some work outside of class in the next few days. But I promise after the exam, we will take a break and things will be much more relaxed in our class. Thank you guys for watching. Please contact me with any questions.